Hello everyone. This is Urvi and I welcome you to a two-part Python series by Scalar, where we'll be covering the basics of Python programming language and DSA in Python in part 1 of the series. In part 2 of this series, we'll be showcasing our learnings in the form of 3 projects in Python that will be beginner to intermediary level projects. So if you've been planning to start learning Python, this is where you start. Before we get started, make sure to check out Scalar's free masterclasses taken by industry experts on Scalar's event page. The link is in the description. Starting with the part 1, I've divided this part 1 of the video into 4 sections. In the first section, we'll cover the basics of programming. We'll cover how to print an output in Python, how to take an input, what are variables, what are different data types and different types of operators. In the second section, we'll move to control statements where we'll see what are if-else statements, what are loops, for loop, while loop. In section 3, we'll move forward to seeing what are lists, tuples, set, dictionary, and how do we use them in Python. And in the final section, section 4, we'll cover what are functions and how to use them in Python. So starting with section 1, let's first understand why Python. Okay, why is Python considered to be one of the most popular programming language and why you should bother learning it? So multiple reasons for that. Number one reason could be that this is a very beginner friendly language, and that is the reason why this language is also taught popularly in high schools as well. And what makes this language beginner friendly is it has an easy syntax. The syntax of this programming language is very near to the English language that we converse in. That is why it is easy to understand, easy to write, and easy to read as well. But the major reason why what makes this language so popularly used everywhere is its versatility. Now, this programming language Python has a number of inbuilt modules and libraries which enable us to use this language in multiple domains, be it ML, be it AI, be it web development, be it app development, be it data analyst, anything, multiple domains, even IoT, blockchain, all of these domains, you can use Python programming language in this, and that is why this programming language has been popular for so many years and will be popular for the coming years. So if you are starting with any of these domains, you will need to have some basic understanding of Python programming language, especially if you're going into ML, AI or data analyst. So in this video, we'll try to focus only on the basics of Python programming language. That will be enough for you to venture into any of these domains and start looking at how to use Python programming language in these multiple domains. Now, the first program that you write in any programming language is a hello world program, where we try to print hello world in that particular language. So first of all, let's try to do that. How would we print hello world in Python? Let's start with our first Python program. Switching to the code, here I'm using VS Code as my code editor. You can use any other code editor as well if you're comfortable with that. If you don't want to go through the hassle of downloading and setting up a code editor, you can also try an online code editor. Okay, that is very convenient to use. But if you are a developer, if you're venturing into software programming, it's always good to set up a particular IDE, and VS Code with a lot of extensions is considered to be one of the best IDEs to use, especially for students. So here I've created a folder in which I'll create my first Python file, and let's name it hello world.py. py is the extension for all my Python files. Now here, to print hello world, I use a function called print. Inside print function, I can mention what I need to print inside quotation marks. Inside quotation marks, if I write hello world, and I run this Python file, it will give me an output hello world. Okay, I can, if I want hello and world in two different lines, I can add a next line character here. So this \n basically is a next line character. This tells Python that, okay, this is where you need to break and put the rest of the part or rest of the text into the next line. So if I run this, I get hello in the first line and world in the second line. Another way to do the same thing is if I use two print statements. Okay, if I use two print statements, it will do the exact same thing. Why? Because this print function, which we're using here to output text onto our screen, this by default adds a next line character at the end. So here at the end of hello, by default, it will add a next line character. If you do not want it to add a next line character, if you want hello world to come into the same line, but you want to use two print statements for it, we can also do that by mentioning end character. So by default, the end character means what gets implemented at the end of the text, at the end of the text that we have mentioned here. So by default, this is next line. If you don't want it to be next line, we'll just say pass it as an empty text, empty string. And now if we see, it just comes into a one single line. Okay. We can also put just space here. So we'll have space between hello and world. So this is how you print output to a screen in Python. Okay. And what I'm using here inside print function, this for now you can just consider this as a text. Moving forward, we'll see that this is a string data type. We'll learn more about it. Obviously, we'll see what exactly are data types and what are strings in this. But for now, you can just understand that we're using a function print. Okay, this function is an inbuilt function in Python, which helps us to output any text onto our screen. Moving forward, let's see what are commons in Python. So whatever code I put here in my Python file, that will get executed when I run this file. If I want to put some text into this file which I do not want to get executed, for example, I just want to mention here that this above code that I've written here prints hello world. I want to just write an extra thing in the code, add an extra thing in the code which I do not want to get executed, but it is just there so that it tells me something about the code. Okay, so I want to mention that this above code prints hello world. Now, of course, this is giving me an error here because this does not follow the syntax of Python programming language, but I want to add this here. So I'll make use of comments here. How do I comment this line? I use the hashtag. So now this particular line is a comment which will be there in my Python file, but it will not get executed. Okay, if I want to add multiple lines, for example, I want to add another line, this is also a comment. So I want to now put both of these lines as a comment, okay, multiple line comment. For that, I can use triple quotations, okay, single or double, and this will help me to have multi-line comments. Okay, so these comments, a basic thing you'll find in every programming language. These are just there so that, you know, if you're putting any code and you want to put some explanation or something about the code in the file so that whoever is reading your code can understand what your code is doing. So for that, you put comments in your file, and it's generally considered a good practice to do so. Moving forward, let's see what is Python CLI. Now, CLI stands for Command Line Interface. Command Line Interface. And this is a very interesting thing, okay? What this will do is this will open a command line interface for us where we can put in commands, Python commands, and the computer will just execute those commands and give us the output side by side. So to open this Python CLI, what you need to do is just you go to the terminal inside your IDE, or you can open the terminal app on your computer and you type Python 3, whatever is the version you're using for Python, and that opens the Python CLI for you. Now, what do I mean by I can keep putting commands and it will keep executing for me? For example, I can give it a command to print something. Okay, I'm telling it to print hello world for me. So if I press enter, it will just do that. It will just print hello world for me. I don't need to run the program, go and save the program and then run it. I can just put the commands here and it will execute those commands for me. I can even do some mathematical operations. For example, I can ask it what is 3 plus 4, it will give me the answer. What is 5 into 6, it will give me the answer, and so on. So basically what I'm doing here is I'm just putting in the commands, giving some commands to the CLI, it is executing them and side by side giving me the output. Okay, I can exit this by pressing command plus D, sorry, control plus D. Okay, do try the Python CLI as well. For like if you want to just quickly check something that how will this get executed in Python, Python CLI is a great way to do that. Moving on to an important concept in any programming language, which is variables in Python. Okay, let's try to understand first of all what are variables in any programming language, not just Python. Variables are containers. These are containers where you store some value or some data. For example, I have my code. In my code, I want to store the age of some person XYZ. Now to store the age, which could be, for example, it's 20, I need to store that value 20 into a container. That container will be called a variable. So how do I create that variable? I can first choose a name of that variable. For example, I choose the name as age as the variable name by which that variable will be referenced or called. I create a variable age and then I can put any value into it, any data into it using the assignment operator. So I can say age is equal to 20. Now what this is doing is, this is creating a variable by the name of age and it is assigning it a value 20. Okay, what kind of a value is this? This is a value, this is a integer value. This is a integer value 20 that I'm assigning to a variable age. Now if in my code I want to do any operation, for example I want to add some years to the age of this person, I want to subtract some years, okay, I want to print this age of that person, I can just use this variable age to do that. Alright, so that is what variables help us to do. They help us to store some value, some data, and also perform some operations on those variables. Let's see how we can create these variables in code. Let's write a program for that. Variables.py. For example, I want to store the details of a person, John. So I can create first of all a variable name in which I store the name of that person. Now the name of the person will be of type text, right? So that type is called string in programming, and for string, if you want to put any variable of type string, the value will come in double quotation marks. So in double quotation marks, I can store the name of that person, John. So now this name is a variable that stores this string John. Similarly, I can say age of this person is 20. I can say the country, okay, the country of this person is India. Okay, so now these are details of John, for which I've created 3 variables: name, which contains the name, the age, the country. All right, we'll see how we create more variables. But before that, let's check out some naming rules. So the name that you give to your variable, that cannot be random. Okay, there are some rules defined in every programming language that tell you what all things you need to take care of when you're creating a variable. Okay, these are the guidelines that you need to follow when creating variables. The first one is that the variable names can contain only letters A to Z from first in small case or uppercase, digits and underscores. Okay, that means it cannot contain any other special character, for example star or dollar sign or any other special character. It cannot contain even a space, a space it cannot contain. It can only contain A to Z letters, 0 to 9 digits or an underscore. Then the first character of a variable name cannot be a digit. The variable name should always start either with a letter or an underscore. It cannot be a number. Variable names are case sensitive. Okay, so if you write a variable name that has small case and one that has mixed small case and uppercase, those are 2 different variable names because these are case sensitive. Fourth, which is a good practice to follow, we should use descriptive variable names that reflect their purpose. For example, if you want to store the name of a person, create a variable name that tells me that it is a name of a person. Don't just have random variable names, for example A, B, C, X, Y, Z, whatever. Obviously you can create those variable names, but it's not a good practice. The good practice is to always create variable names that tell us what kind of value or what that variable name is holding. And lastly, the naming convention. So in Python, the naming convention basically tells us how to, what is the best practice to name our variables. We follow the convention of naming variables using snake case rather than lower camel case, and this comes in when we have multiple words in a variable. Okay, for example, I want a variable name, name of person. Okay, name of person, I want this to be my variable name. So now this has multiple words, name of person. So in Python, we follow the naming convention of snake case. What is snake case? In snake case, we basically separate these words out by underscores. So this is the right way of creating a variable in Python rather than lower camel case. What is lower camel case? Lower camel case is basically that, for every word, the first letter becomes capital instead of, except the first word. Except the first word, all of the rest words, the first letter will become capital. So this is the lower camel case, which is not followed in Python. In Python, we follow underscore convention. Okay, let's cover this. These again are some keywords in Python. What are keywords? Basically, these are reserved names in Python. So when you're creating a variable, you cannot use these particular keywords to name your variables. Okay, and you can see some of these. I'm not going through the entire list, but for example, none. Okay, none here is a keyword in Python. So you cannot create a variable name with none. It's a reserved keyword. If you do, it will throw you an error. Okay, and now quickly, let's do an exercise. Let's do an MCQ round where you'll tell me which of these variable names in Python are invalid, which are not valid variable names. Okay, and also you have to see why these are not invalid. So starting with the first one, First one you'll see, is this a valid one? It's not. Why? Because this starts with a digit, and we just saw that a variable name cannot start with a digit, either with an underscore or with a letter. So this is not invalid. So this is not valid. This is an invalid variable name. The second one, Scalar Academy. Now again here in between scalar and academy, you have a space. You cannot have space in a variable name. You can have either scalar as a variable name, either academy as a scalar name, but if you want to have these two words in a variable name, you need to separate these by an underscore. Okay, so if this had an underscore between the two words, it would have been a valid variable name. But because it does not, then it's not valid. It's an invalid variable name. The third one, again, we can see this clearly, false. This is a reserved keyword in Python. So you cannot create a variable name as false. D, apples, underscore apples. Is this a valid one? Yes, this is a valid one. Why? Because we're allowed to have underscore as the first letter. We're not allowed to have digits, but we're allowed to have underscores. And lastly, E. Again, this is invalid. Why? Because of these special characters. We cannot have any special character except underscore in our variable names. Okay, so make sure to follow these naming conventions whenever we're creating variables in Python. Variable types. Now, if you have already learned some other programming language, you'll know that in languages like C++ or Java, while creating a variable, we generally mention what is the type of that variable. Okay, that type can be an integer, that type can be a string, that type can be float, which is for floating integers, the type can be bool. But in Python is considered to be a dynamically typed language. For example, which basically means that we do not need to specify what is the type of the variable when we create a variable. Okay, so for example, if I had to create a variable age in any other programming language, I'll probably have to mention with the variable name what is the type of the data or the value that that variable will be storing. So I'll have to mention, okay, that it will be age variable of type integer, and then I can put some integer value into it, and then I cannot put any other variable type value into it. If I have mentioned that it is an integer type, it will only contain integer type, but that does not happen in Python. Which again, one of the good things about Python, we do not have to decide the type of the variable when we are creating it. Let's see this in code, okay? For example, I've mentioned here that the age of John is 20. But now if I want to, right now it's an integer, okay? This is an integer value that I've stored in the variable age. What if I want to change this value into a string? Okay, I want to put 20 as a string here and not as an integer value. So I can just simply change it. I can just put here, okay, this is 20 now. So now the age value gets updated to 20. Okay, we can also check this. Okay, let's check this. Let's print age here, and we'll print age here. Okay, by the way, for printing any variable name, you can again just use the print function. And here, because we're not printing any string, we don't need to put this inside quotation marks. Okay, we can just put the variable name and it will print the value that is stored in that variable. So let's see. If you can see here, first of all, what gets printed? 20 as an integer and then 20 as a string. So what happens is, here when we put 20 as an integer value, it created a variable which stored an integer value 20. After that, I can reassign that. variable. I reassign that variable to a string value. So here it has a string value. So here it will not create a new variable. It will be the same variable, but just the value will get updated. Okay, so that is what is followed in Python. If you create a variable name that does not exist yet, it will create a new variable name. If you use a variable again, okay, if that is already defined above, then it will just update the value of that variable. In Python, what we learned is it is dynamically typed, where we do not need to mention the type of the variable when we are defining it. And we can also update the value. So if initially it had an integer value, later on we can put a string value into it, and probably later on we can also put a boolean value into it or floating value into it. Of course, these are different data types that we'll cover in detail just in a minute. But before that, I've already covered reassignment. I can reassign the values. Okay, if it's not immutable, meaning given the age variable some value 20, I can also change it to 21 later on. And I can also do multiple assignments of variables. How can I do that? For example, I want, instead of assigning these variables separately, I want to assign them together. Okay, I'll just comment this code out and I'll say name, age, country, and then I can assign the values to these, which will be assigned respectively to the variables. Okay, so I say John, comma 20, comma India. So again, now name will have the value John, age will have the value 20, and country will have the value India. So this is how you can also do multiple assignments for variables. Okay, in one line you can create multiple variable and assign them values. Let's try to print these values now. Let's see how we can print these values. So for example, if you want to just print the variable values, okay, that is simple. I can just print name, age, country, and I can separate these by commas. Okay, so that the function knows that these are three separate things to print. So this line here will print John, 20, and India. Now, for example, in the string, in the print statement, I also want to mention what exactly this is printing. Okay, so that means I have to print the variable names and also some string that tells me what that variable name is printing. Okay, so how I can do that is I can mention in quotation marks the string name is equal to comma the variable. So what this does is basically these comma separated objects in our print function will tell us that these are different items. Okay, so first of all, this will print this name as a string, name text as a string, and then it will print the name variable value, what value is stored in the name variable. Similarly, I can say age is equal to this and country is equal to this. Okay, so we forgot a comma here. Okay, so now you can clearly see what these variable names are. Name, comma, the variable name, then age, comma, variable name, and so on. So this is one way when we want to print variable names along with some string, we can use commas to separate them out. Instead of the commas, we can also use plus sign here. So So the plus sign here will do the same thing as the commas. So we can separate the strings and the variables through plus sign, and it should print the same thing here, except this age, what this plus sign expects is a string. Okay, so here name and country are strings, so that is fine, but here age is an integer. So this plus operator basically concatenates two strings. What do you mean by concatenation? Concatenation means putting one string ahead of the other or the back of another string, basically joining two strings together. So it expects two strings. Now here, because we are putting h, which is an integer, that is why it is saying that it can only concatenate string, not integer. So for example, instead of 20 here, if I pass another string only, okay, 20 as a string only, then this works, right? This works then. And here you can see, of course, there is some difference, because in terms of comma, we were having some space, which was by default added here, because when we are using commas in print function, by default it uses space as a separator. But that does not happen in plus sign. When you're using the plus sign, it's basically concatenating the strings together, putting one string at the end of another string. Okay, and these are two ways to print. Of course, there's also a third way, using formatted strings. Okay, and this is only there in Python 3.6 and higher versions. But what you can do is, for example, I wanna print one string, name is name, age is age, and country is country. Now here, I know it's confusing, but what we're trying to do is, here the name, this age, this country, these are variable names. So how do I tell Python that these are variable names and not to be printed as a text? I basically put these variable names in curly brackets. Now the name, age, country here, these are inside the curly brackets, these are variable names, and outside of the string I mentioned f, which basically tells the print function that this is a formatted string. So now see what is happening here. This is the line that is getting printed. So name here, which is inside the curly brackets, is being taken as a variable. So its variable value, which is John, is getting printed. Okay, so this is just another way by which you can print variables along with strings using the print function. So we've covered what are variables. We've seen the naming rules for variables, what are the keywords not to use for variables, and we've seen how to assign these variables, how to reassign, how to print these. Now, I also told you that these variables can be of different type. Now, although in Python, you do not really need to worry about the type. Why? Because you do not need to tell the code what type of variable you are making. When you are making it, you can just put the value into the variable name, and Python is smart enough to deduct that, okay, if some integer value is being placed inside the variable, then this variable type is of integer. Okay, let me also show you how to check the type of a variable. So let me comment this out. If I say age is 20 and name is John, and I want to see now what are the types of these variables, name and age. For that, I can use the type function. So inside the type function, you place the variable name, which is name here, and this will tell me what is the type, the data type of this variable name. Okay, and let's also check the data type for age. So see, it tells me that the name variable that belongs to class string, str stands for string, and the age variable belongs to the class integer. Alright, so these are the different data types that you have: string, integer, and much more. Let's look at these. First of all, the data types. These are, what do they tell you? They tell you what type is the data or the value that you're storing. What can be the different types? First of all, it can be a numeric type of data, and in numeric again you can have multiple. First of all is int. Okay, for example 20, 0, -4. These are all values of type int. Then you have float. Float stands for, data type stands for floating numbers which have decimal points. So for example 3.14, 0.08. These are all values of type float. So if I create a variable percentage is equal to 98.7, so that means the percentage variable here is of type float. And lastly, complex. This is for complex numbers which have a real and an imaginary part. For example 4 plus 2j and so on. Next we can have text type in Python. Basically what we've been using so far to print things in our print statement, right? That is type string that I've been telling you. So how do you know if it is of type string? You basically add it in between quotation marks. That can be single quotation marks or double quotation marks. In both ways it will take it as a string. Okay, so for example hello here, if I'm putting in quotation marks, that's a string. World here in double quotation marks, that is a string. The third is Boolean. Now this might be a new type that you might not be familiar with. Bool, what does bool stand for? Boolean stands for two, basically two values. And Boolean type can have only two values, true or false. It can have two values, true or false. Okay, it cannot have any value except these two values. So if I am creating, for example, I'm creating a variable that tells me if a number is positive. Okay, so I create a variable is positive, which tells me if a number is positive or not. So this variable, I can give it value either true or I can give it value either false. In this case, this variable is positive is of type bool. And lastly, none. None is basically for containing null value. Okay, this is a special data type which contains null value. So now we've seen what are variables, what can be the different types of variables. Now moving forward, let's see how to take input from a user. For example, I want to write a program where I want to give the name, age and country of a person. How do I do that? For that, I use the input function. I use the input function in Python that takes the input from the user, and then I can store that into some variable. Okay, some variable name may I can put that value whichever is input by the user. Now one thing to remember, important thing to remember about this function is whatever value you put in. Okay, for example, I can type anything to the computer, I can give any input, I can give it a string, I can give it a float, I can give it an integer, I can give it a bool value, anything. But what value it takes is of type string. So whatever I am inputting here, it will always store that value as a string. So this variable will always belong to class string. Okay, let's see this. So now I want to take the name of a person as an input. So I can say name is equal to input, and inside the input function I can put a text which tells the user what they want the input for, or okay, basically a cue that this is where you enter text. If I just put this here, it will, basically it will allow me to put text. I can put a name John, but how do I know that this is, where it is asking me for some user input? So inside the input function, I can enter a string. I can say enter a name. And now readability wise, it's better because now I know, okay, here is where I need to give some input to the program. I can mention here John, and this John will be stored in name. So let's also try to print that. Let's print name is whatever the name we've inputted, and let's also print the type. Let's also print the type of this variable name. Although I've told you that it will be a string, but let's verify, okay? So I mentioned a name John. The name it takes as John in the name variable, and this name variable is of class string, as we can see here. Alright, so this is how I can ask user for an input in Python. Now, what if I want to ask for an integer value? Okay, for example, I want to ask for the age of John and want to store that in my program. So age is equal to input enter age. So this will basically take the input age, and this print statement here will print the age that I have inputted to the program. And let's print the type. What will be the type of age? So okay, name John and age 20. So now here the age variable has value 20, but this value 20 here is not taken as an integer value. It is taken as a string value. Okay, so this age variable, if you print the type of it, it will show you string class, not int, because the input function by default, whatever input you give it to it, it will take that value as a string. Now, what if I want to store this value as an integer only? I don't want to store the age value as a string, but I want to store it as an integer. There's a way to convert it from string to integer, and that is known as typecasting. That is known as typecasting. What is typecasting? You basically convert one data type to another data type, and it's very easy to do this. For example, I have a string age, okay, and it has this value. I want to convert this to int type, so I just put the data type and the variable name. So this will return me, I can store this value into some other variable name. For example, I can say age number is equal to int age. Now this age number here, this variable will be of type int, because I've converted the data type of age variable from string to int. Okay, let's see this in code. If I where we're taking input, at that point only we can typecast it into an int. What we'll just need to do is we'll typecast it using int function. So int, and whatever input is giving here, now the age will have the variable of type int. Okay, let's try this. John, that's of type string, age 20, and now you can see the age of that person, the age variable that belongs to class int now. Okay, so you can use typecasting to convert any data type to any other data type. You can convert string to int to string, int to boolean, or boolean to int. You cannot convert boolean to int, but basically it will take any number except 0 as true, and then it will take 0 as false. You can also convert int to float and vice versa, and so on. Now we've seen what are the variables and what all you can do with them. How do you perform operations on these variables? Okay, for that you have a number of operators in any programming language, and these can be different type of operators. Firstly, we have arithmetic operators. Okay, arithmetic operators are basically used for performing the basic arithmetic operations like addition, subtraction, multiplication, division. You all are aware of these. Then we also have float division, which what it does is it divides the left operand by the right operand, and it also rounds down to the nearest whole number. Okay, so division will basically return a float, but float division will return me an integer because it will round it to the nearest whole number. Modulus will return the remainder of the division. Basically, if I say 5 modulo 2, so what this will do is it will divide 5 by 2 and it will return me the remainder. If I divide 5 by 2, what will the remainder? The remainder will be 1. So it will output me the remainder of that operation. And lastly, exponential, which raises the left operand to the power of the right operand. Okay, so these are different operators, and you can just try these arithmetic operators out in the Python CLI itself and just see how this is working, what output these operators are giving to you. Next type of operators are assignment operators. Assignment operators are basically they assign the value. So you have the assignment operator equal to, which we just saw we use while creating variables, while assigning values to the variables or updating the values of the variables. Then we also have some other assignment operator, for example, plus equal to. What this does is it will perform that operation of addition, and then it will assign the value of the operation to the left operand. So if I'm saying a plus is equal to b, so this basically means a is equal to a plus b. So it will do a plus b, and then it will store that value into the left operand, which is a. And this similar thing is followed for all of the rest of the operations. Number 3, these are comparison operators. So, for example, you have two values and you want to compare those values. That's when the comparison operators come in. The equal to operator checks if two values are equal or not. For example, if I have a variable a which has value 3 and I have another variable b which has a value 4. If I check here a equal to b. So what this will do is it will compare these two variables for me, a and b, and it will tell me if these two values are equal or not. So here, of course, a and b are not equal, so it will return me false. So comparison operators will return me Boolean values, either true or false. If they were equal, it would have returned me true. They're not equal here, so it is returning me false. Similarly, we have not equal to, which basically checks if these two values are not equal to, the left operand and the right operator. We have less than, greater than, less than or equal to, or greater than, equal to. So if I do a, if I check a more than b, is a more than b? No, it's not. Again, it will return me false. Okay, and so on. Lastly, we have logical operators. These logical operators, they run on Boolean values, you can say. So, and or not. You might have studied about these earlier, but what these logical operators do is basically and operator will return me true if both the left and the right operands are true. Otherwise, it will return me false. So, if I have some value that is true and I do and another value that is true, that will return me true. In any other case, okay, if any other value is false, for example, if it is false and true, if it is true and false, if it is false and false, in these three cases it will return me false. For OR operator, what it does is it will return me true if any of the operands is true. So true or true will give me true, of course. True or false will also give me true, because at least one of the operand values is true. False or true will also give me true. False or false will give me false, because this has none of the operands as true. And not, what this operator does is returns the opposite Boolean value of the operand. So basically, if a value has true and I say not t, so that will give me false. If I say not a false, that is true, and so on. So we'll use some of these operators ahead in some of the programs, and you will see how to use them. As and when you get to use them in the program, you will get accustomed to them, comfortable with them. Moving forward to section 2 of our part 1, which is control statements. Okay, and this is where we'll write a lot of program, and we'll try to use the knowledge that we've gained so far about variables, data types, and operators. Okay, so firstly, let's try to see what are control statements. Let's try to understand what are control statements. Control statements are statements that you use in a program to control the flow of our program. And one type of control statements are conditional statements. Conditional statements basically check a condition and execute the code according to that condition. So a lot of times in code we might have the we might need to follow some condition. For example, if this is happening, then we'll do this, else we'll do something else. For example, if it is raining, then we need to take an umbrella. If else, we don't need to take an umbrella. If a similar thing, for example, we have to implement in code. For example, if we are dividing two numbers, we're dividing two integers a, b. Now we want to check if b value is not equal to 0, then we'll divide a by b. If b is equal to 0, so we'll not divide. Okay, so basically what is our condition? Our condition is if b is not equal to 0, only then we'll execute this. So for that we use if-else statements. What is the syntax for this? We mention if, the condition, and the code to execute if that condition is true. So if b is not equal to 0. Okay, so we're using the not equal to operator here, and these brackets are optional here. You can do without these as well. But whatever code you want to execute here, if this condition is true, should come at an indentation level. Okay, indentation is very important in Python. So Python is a programming language where we try not to use the brackets, but we try to mention the flow of the code using indentation. So without the right indentation, even the build will fail. Okay, so the code to execute will mention at an indentation level if this condition is true. So this is our condition here. If the condition is true, then this code will get executed. If condition is false, in that case the else part of the code will execute. Else part of code. Okay, once again, in front of if we mention a condition. If that condition is true, we will execute this code. If that condition is false, then we'll execute this code, the else part of the code. Let's try to see this in code. So for example, we want to write a program to check if a particular number that we take input from the user is odd or even. Okay. So what we can do is, first of all, let's ask for a number from the user. Enter a number. Okay, and we want this to be of type int, so we'll typecast it into int. Next, we want to check if this number is odd or even. So what is the condition to check if a number is odd or even? We can check using modulo operator. If the remainder when we divide a number by 2 is 0, that means it's an even number. If it is not 0, then that means it's an odd number, right? So if, then we'll write our condition. What is our condition? If number modulo 2 equal to 0. So this here is our condition, that number modulo 2, when I divide the number by 2, the remainder, if it is equal to 0, that means it's an even number. That means it's an even number. So I can print it is even. Else, if this condition is not true, if it is false, then then the else part of the code will get executed. So in that case, we'll print it is odd. And if I run this, let me input 33. So it is telling me it is odd. If I mention 46, it will tell me it is even. So a simple program to check if a particular number from the input is even or odd using if-else statements. Now we can also have another else if. For example, we want to, we have some other condition as well. So right now here, while checking an odd even, we have only two cases. Either it can be when I divide the number by 2, either it can be, the remainder can be 1 or it can be 0. What if I divide the number by 3? Okay, in that case, the remainder can be 0 or 1 or 2, right? So I'm just trying to show you an example where we might have another check or another condition. Okay, let's try to do something else. So for example, if the user gives you an input and you want to tell that when you divide it by 3, what is the remainder? Or let's do something else. I want to check if a number that is given by user is divisible by 3 and 5. Okay. So I can check if a number is divisible by 3. Again, I just need to check using the modulo operator. If it gives remainder 0 on dividing by 3, that means it is divisible by 3. In that case, I can print number is divisible by 3. I have another condition here now. Another condition where I need to check if the number is divisible by 5. So you can use the else if statement here for another condition. So I have another condition where I want to check if the number is divisible by 5. So if number is divisible by 5, this gives remainder 0, then I'll print number is divisible by 5. And now we can have an else statement. So if both of these conditions are false, okay, if first condition is true, this code will get executed. If second condition is true in else if, this code will get executed. If both of these conditions are false, then it will move to else case. So if both of the above conditions or all the above conditions are false, then it will move to the last case, which is the else case. Number is not divisible by 3 or 5. So this is how you can use if else. You can also combine multiple conditions, okay, using and or. We just saw and or as logical operators which work on Boolean values. So if I have, for example, two conditions, I have condition 1 and I have condition 2, and I want to combine the result of these two conditions. So I can use and या फिर or there. If I use and operator, that means if both of these conditions will be true, then the result or the combined result of this will be true. If I use the or operator here, that means if either of these conditions are true, then the combined result will be true, else false. Okay, so for example, I can, if I want to check in a single condition if the number is divisible by 3 or 5, or if I want to check if the number is divisible by 3 and if it is divisible by 5, it is divisible by both of them. So what I can do is I can combine these two conditions. I can say if number is divisible by 3, that is my condition number 1, and my number is divisible by 5. So this is my condition number 2. If both of these conditions are true, then that means that the number is divisible by 3 and 5. Else, the number is not divisible either by 3 or it is not divisible by 5. Okay, so this is how you can also combine multiple conditions. Moving forward to the next control statement, which are loops. Okay, what are loops used for? For example, you want to do something in code repeatedly. Okay, you want to repeatedly execute a piece of code. In this case, you use loops. For example, I want to print numbers from 1 to 10. Okay, and I don't want to code the print statement 10 times. So I can use a loop here. There will be two types of loops that we'll be studying: for loop and while loop. For loop basically loops over a range or a sequence. So it will loop over a sequence, which can be a list, it can be a tuple, or it can be a range, some range of numbers. Okay, so we have a function range that basically gives us a range of numbers, whatever we mention. So if I'm mentioning 0 to 9 here, so it will give me a range of numbers from 0 till 8. So the starting point is inclusive and the ending point is exclusive. Okay. So if I want to loop over this range, I'll say for item in this range, and here I'll mention the code to execute. So what will happen here now, this code will get executed 9 times. So the first time this item, this is a variable that will loop. In the first iteration of this loop, item will have a value 0. In the next iteration, it will have 1. In the next iteration, it will have 2, and so on till 8. So this loop will get executed 9 times. Every time this item variable value will get updated, because it will go through a sequence of numbers from 0 to 8. Not till 9, because 9, the ending point, is not included in that range. Let's see this in code. So for example, I want to print numbers from 0 to 10. I can use a for loop for item in. This item, this is basically a variable that will be used by me to loop in the sequence. For item in, I can mention some sequence. I can mention a range of numbers from 0 till 11. Why I'm mentioning 11 here? Because 11 will be exclusive. So it will only go till 10. I can also mention 1 to 11. So it will go from 1 to 10. And I can use the print statement here, again at an indentation level, to print item. If I run this, you see what happens? It will print 1 to 10 numbers for me. In just 2 lines of code, I'm able to print 1 to 10. So I don't have to write the print statement 10 times here. I've created a loop that will run 10 times and will print the number for me from 1 to 10. This range function, you can also just mention, if you just mention one number, that will be ending point. So in this case, it will go from 0, it will start from 0 to 10. So here, you can either put starting point, ending point, or you can just put the ending point. In that case, the starting point by default becomes 0. Okay, so this is one way of using loops, using for loops. For loop, what it will do is, it will iterate through a sequence where we can give a range, we can give a list or a tuple, which we'll be studying ahead. In loops, we also make use of control flow statements that are continue and break. Continue statement, let's study about break statement first. So break statement, I can mention in a loop, and what it does is, it will break the loop. Or I can say it will stop the loop. Wherever I say break, that means that the loop will be stopped. Continue statement is used to skip an iteration. If a particular, the loop is iterating 10 times, for example, I want to skip a particular iteration of the loop. In that case, I can use the continue statement. How? Let's see. For example, I am printing numbers from 1 to 10, and I say I want to break the loop if at the 8th iteration, whenever it reaches the 8th iteration, I want to break the loop. So I can put a if condition here, if item is equal to 8. In that case, break. So whenever this item value, which we are using to iterate here, becomes equal to 8, which will become in the 8th iteration, at that time it will break, meaning that this loop will break. There will be no further iterations of it. Okay, let's try run this. So you can see here only till 7 values are getting printed. In the 8th iteration, this condition becomes true and it breaks the loop. What if I want to not break the loop at 8th iteration, but I want to skip that iteration? I don't want to print 8. I want to print all of the numbers from 1 to 10, but not 8. So in that case, I use the continue statement. Now, what you can see is 1 to 10 numbers are getting printed, but there's no 8 here, because when the iteration reaches 8, it hits the continue statement, and what it does is, it will skip whatever is written in the loop after that, and it will move forward to the next iteration. Okay, so continue and break statements we use in loops a lot. The second type of loop is while loop. While loop, what this is doing is, this is looping or iterating until a condition is true. So for loop was iterating through a sequence. While loop iterates till a condition is true. So basically, when mentioning a while loop, we mention a condition with it. While a particular condition. So till the time this condition is true, this loop will keep running. As soon as this condition becomes false, this loop will break. So again, if you want to print numbers from 1 to 10 using while loop, how we'll do that is, let's create a variable for iterating item, let's call it, and let's say the value is 1. Now while item is less than equal to 10. So till this condition is true, till the item value is less than or equal to 10, till then that this while loop will keep executing. And now here we can put the code that we want to execute every time. So we can print the item value, and we'll also need to update the item value so that at some point it reaches this condition 10. Okay, if it never reaches 10, this will just be an infinite loop. It will keep running. Okay, so I can update the value item where I'm just adding 1 to the item. So this basically means item is equal to item plus 1. So I'm adding 1 to the item value every time in the loop, so that at some point it will reach 10. Okay, now if I run this, see, it starts with 1 and it will go till 10. As soon as the item value becomes 10, because I keep adding 1 to it, so at some point after 10 iterations, after 9 iterations, the value will become 10. So at 10 the code will get executed, because the condition is as long as item is less than equal to 10. When it is 10 and I add 1 to it, the item value will become 11. Now that's when this condition will become false, because 11 is not less than equal to 10. And as soon as this condition becomes false, we'll come out of this while loop. Okay. Again, in while loops, you can use break and continue statements to control the flow of the loop. And we've covered the section 2 as well. Section 3 of this series, this is what will cover the collections in Python. So data structures in Python, we basically have 4 data structures: list, tuple, set, and dictionary. And we'll try to cover the basics of these data structures that will let you use these, implement these in code for basic uses. So let's start with list. That is the most commonly used data structure that you'll be using the most as well. Now list here, it is used to store multiple values, and there are some attributes of every data structure that you need to remember. If you do that, you will be good to go. So all of these collections in Python, they are used to store multiple values. But what are some attributes that make them different from the others? Number 1, this is an indexed sequence or an indexed collection, meaning, okay, how do I create a list? I create a list using square brackets. So if I want to create a list in code, I'll say list is equal to this. This will create an empty list for me. And I can also put any values in this. So I can place 1, 2, 3. So this will create a list for me with values 1, 2, 3. Now here, what I mean by saying that these are indexed, lists are indexed, meaning the first item in my list will have an index 0, the next item will have an index 1, and the next item will have an index 2. So these indexes basically tell me, they help me to locate a particular element, and indexing will also enable you to access any element in a list. So in a list, all the elements are indexed. Basically these indexes tell where that item is located in the list. So lists are indexed. They are mutable, meaning I can change these lists, I can update the list, I can add, remove items to the list. Number 3, lists are, so they are indexed, they are mutable, and they are ordered. Yani ki whatever items I add to the list, they will get added to the end of the list, and all of the existing elements in my list will have a particular order. They'll not be present in some random order. And you can, in a list, you can put any data type. So the values in a list or the items in a list can be of any data type. So you can even have a list which has one value of type string, another value of int, another of floating, and so on. And it can also be a list of lists. So one data type that you can put in a list is a list or some other collection as well. Now I told you that you can index a list. How to do that? How if I have a list which has some values 1, or let's remove this, let's say 10, 20, 30. This is my list. How do I index the elements? The first element will always be at index 0, the second at 1, the third at 2, and so on. So these elements are 0 index. That means the first element is always at index 0. So if I want to access the first element of my list, I'll say list 0, and this will enable me to access, this will give me 10, the first element of my list. This is positive indexing. I can also do negative indexing, which is from the end of the list. So if I say list -1, so this will give me the last element. So the last element will be present at -1 index, second last as at -2, third last as at -3, and so on. I can even do indexing in ranges. So for example, I have this list 10, 20, 30. And I want to access a part of the list, a sub list basically from 10 to 20. How do I do that? I mention a starting point and an ending point. So the starting point here will be 0 and the ending point will be 2. Why 2 and not why 1? Because I want to access 0 and first element. So it should be, the ending point should be 1. But when we are putting indexes in a range, the ending point is exclusive and the starting point is inclusive. So basically this will give me the range of elements from 0 to 1 index. And similarly in negative indexing, if I want to have -1, -2, -3. So in this case, I'll go from -3 to -1, sorry, because again the ending point is exclusive, so I'll have to mention the index, the last index -1. Okay, so basically if I'm mentioning -1 here, it will take till -2. Okay, so this is how we can access items in a list. Let's see how to implement list now and how to traverse a list. So I can create a list 1 with some fruit names, for example, apple, banana, and cherry. If I want to print just one item of the list, okay, for example, the first item, so I can just do list 1 0 index. That will just print the first item, which is apples. If I want to traverse through the entire list, I can use a for loop. So for item in list 1, I can print item. And what this will do is, this will print all of the, let me comment this out. This will print all of the items in my list. I can also add elements to my list. So I can do list1 dot append guava. And now if I print the list, guava will get added to the end of my list. Okay. If I want to insert an element at a particular index, so append will add element to end. If I want to add element at a particular index, I can use list1 dot insert, and I can mention the index at which I want to put, for example 1, and the string that I want to insert. So here if you see, this was our initial list, and in this list at one index, at index 1, I've inserted guava. So using insert function, I can add element to a particular index. Okay, I can also use the update function if I want to put one list at the end of other. Sorry, extend function if I want to put one list at the end of other. To remove elements, this was for adding elements. If I want to remove elements, for removing I can just do list1 dot remove, and what value I want to remove. So for example, I want to remove apples from my list. So you see the updated list does not have apples. Let me just comment this out for clarity. Okay, so initially we had these three, and after removing apples, this is the list that we have left. I can also use the pop function. The pop function will basically help me to remove an element at a particular index. So if I do 1 here, if I place one index here, the element that was at index 1, which was, what was it, banana, that is removed. So again, pop here will help me to remove a particular element at a particular index. You can also change the items in a list. So if I want to update the item, I can just say list1, and at 0 index I currently have apples. I want to have guava. So I can just update it, and now I have the updated list. So it's a mutable data structure. Lists are mutable, so you can change or update the values in the list. You can also sort the list. So if I have this list and I want to sort it, I can say list1 dot sort. This will give me the values in a sorted manner alphabetically. I have some other inbuilt functions as well, like reverse. This will reverse my list. So I have in the opposite, in the descending basically manner of sorting. So I just showed two here functions, sort and reverse. There are also other functions, inbuilt functions, that you will gradually learn as you will implement list for various use cases. Okay, so we covered list. There's a similar data structure which is tuples. Tuple is again used for storing multiple values. What makes it different? This is immutable. This is an immutable data structure, meaning you cannot update the values of a tuple if you've created a tuple once. It is indexed like list, so we can get the elements of a tuple using their index, and it can again contain values of different data types, and these are ordered, meaning the values in a tuple will contain some particular order. The major difference that comes between list and tuples is the immutability. Lists, values you can change, update. Tuples, you cannot do that. How do you create a tuple? Using curly brackets. So if I want to create a tuple, I can just say tuple1 is equal to curly brackets. This will create an empty tuple. If I want to have some value in this with one, if I want to add some value and a single value, I'll have to put the value and the comma. So basically, if I don't put the comma, it will just think that that's a normal, of an integer variable where I'm just putting the bracket. So for it to know that it's a tuple, I need to put the comma as well. Okay. So creating a tuple, I can create tuple1 is equal to, again, let's have the similar kind of values, banana, cherry. Okay, so I have a tuple1 here which has 3 values. Now I can access these elements using their index. So if I want to print the first element, I can say tuple1 0 index, and that will print the first apples here, but I cannot update these values because tuples are immutable. If I want to print all of the values, if I want to traverse, again I can use a for loop for item in tuple1 print item. and this will traverse through the tuple and print all of the items that are present. So this will iterate through the tuple and print all of the values that are present inside my tuple. Now you might think, if we already have lists and lists are immutable, why do we need tuples, right? Because immutability is not really a good thing. But traversing through tuples, iterating through tuples is considered faster. So when time is a constraint for us, we would prefer implementing tuples instead of list. When we want to have mutability in our elements in a sequence, then we would prefer to have lists instead of tuples. Moving forward to sets. Now sets are different from lists and tuples in a lot of ways. First of all, these are unordered. So just like in list tuples, we were able to access the elements through their particular index, sets do not have a particular order. So they are unindexed and unordered. The elements will be present randomly in a set. These are also immutable. So you cannot update the values inside a set. You can add or remove values but not update them. And also lists and tuples were allowed to have duplicate values, but in set duplicates are not allowed, which means if you have some values in a set already and you try to add that again, it will not do that. So duplicate values are not allowed in a set. How do you create a set? You create it using curly brackets. So if I want to create a set in code, I'll say set1, so curly brackets, and I can put some random values in this. Let's go with names this time. Now this set has 3 strings. Again, these strings, they're not ordered, okay? And I can check that by printing these. If I want to traverse through this set to print all of the values, I can say for item in set1, print item. And so the first time I print, see, the order in which these items are printed is random. So here I put John as first, Ria as second, and Prag as third. But the order in which these get printed is random. If I print these again, probably again the order will change. Okay, so in a set, the values are unordered, unindexed. But you can traverse through all of the items using a for loop. You can also add items to a set. So you can use the add method for that. I can add Tina in here, and if I again print the set, I have Tina here added in the set. Again, that will be added at a random position because we are not here tracking the position of each of the elements. If you want to remove an element, you can use the remove function here. I can say remove Tina and print here. So you'll see at the end, you'll see no Tina in the set. Finally, we have the dictionary data structure. This dictionary structure again is very different from the previous data structures because it does not store linear values but key value pairs. It will store key value pairs. What are key value pairs? So for example, you want to have a data structure where you want to store some values, but along with those values, you want to also store the keys for those values, which will tell what that value is giving you. For example, I want to create a dictionary where I want to store the details of a person. Now the details of a person, like we did in the beginning, can contain the name of the person, the age of the person, the country of the person. So again, the name here can be the key, and the value that I actually give to it, John, will be the value for the key name. Again, I can have age as another key, and it will have some value 20. I can have another key country, which will have some other value, India. So here name and age, these are keys for me, and John and 20, these are values for me. So I can create a dictionary called details, okay, where I can have name and some value there. I can have age and some value there. So I forgot the comma here. So basically all of the key value pairs will be separated by commas. And I can have another which is country as India. Alright, so this here details, this is a dictionary where we have keys as name, age, country, values as John 20 India. If I want to print this, or if I want to print some value of a particular key, what I'll do is I'll say print details of name. So the value that is corresponding to the name key will get printed here, which is John. I can also say print details dot get. I can use the get operator to get the value for a particular key. I can also print all of the keys in a particular dictionary by using the keys function. So dot keys will basically give me all of the keys that are present in this dictionary, name, age, country. If I want to print all of the values, the key value pairs in my dictionary, how can I do that? I can either get all of the keys first and then print the values corresponding to those keys, or there's an easier method using a for loop where we mention for key comma value in details print key value. So here in details we'll have to use the function items. Basically items function will provide the list of all of the items, the key value pairs in our dictionary. So now if I print this, I can print all of the key value pairs that are present inside my dictionary. I can also add elements to this dictionary. I can say details and just put a particular key and the value that is corresponding to it. So if I say state is equal to Delhi, and I can try printing this again, the dictionary values. So I have another now key value pair state Delhi inside my dictionary. Similarly, you can remove items from a dictionary using pop function. So you can say pop, and here you can mention the particular key that you want to remove. So again here the state key value pair has been removed from our dictionary. And you can also have nested dictionary, which means you can have a dictionary inside a dictionary. It doesn't have to be, your string integer data type. It can be another list, another sequence that you can have as a type inside that can be the type of the value inside your key value pairs. So we've covered all of the sequential data structures. Here we've covered list, tuple, we've covered set and dictionaries. So this will be good for you to go ahead and start writing programs. One thing that is still remaining for you to understand the basics of programming, that is functions, which will make your life easier as a programmer if you implement them appropriately. So what are functions? And we've seen some of these, so it won't take a lot of time to cover these. The first thing that we saw when we started learning Python was print. Okay, and I told you that print here was a function. What is a function? A function is something that you give an input to it. It will perform some operations and it will give an output, or it will just perform some operations for you. For example, the print function was doing that. In print function, we were giving some input as a text, and it was what output was it giving? It was just printing that onto our screen. So print function here was an inbuilt function that we already have in Python. We also saw the sort function. We saw the reverse function when we were doing lists. These all functions are inbuilt functions, the add, remove, for Python, that we do not need to implement when we are coding. These are already implemented in Python. We can use these directly. Now, what if we want to create a function of our own, where we give some input to it and it gives back some output? Those are known as user-defined functions. And how do you create a user-defined function? This is the syntax for it. First of all, def keyword basically tells us that this is a function. You mention the function name and you mention the parameters that you pass to the function. What are these parameters? These parameters will be the input to the function, the input that we are passing to our function. Those will be the parameters. And then you mention the code, the body of the function, the code that will be executed when that function is called. This code will only be executed when that function will be called. So how do I call that function? I'll call the function by its name and I'll pass the arguments that it expects. So whatever the function definition is telling me what it is expecting as input, that I'll pass here as arguments. So let's see this in code. Let's create a function that will take two integers as input and it will return the sum of those two integers. So I'll create a function by the name sum. Now this sum function expects two integers. Okay? So let's call them a and b. And it will find the sum. Let's call the function add. And it will find the sum as a plus b, and at the end it can return the sum, or we can print the sum. We can just print it here, or we can return it from to where the function was getting called. Okay, so for example, I have some num1 is equal to 5, num2 is equal to 7, and I want to calculate the sum of these two numbers. So I call the function add, where I pass these two variables num1 and num2. So here num1 and num2 will be passed as arguments to this function add, and it will return me the sum. So I can say that the sum, whatever value will be returned to me from this function, I can store that in a variable sum, and I can print the sum here. So here it's giving me 12, 5 plus 7 output. Similarly, you can create functions with endless number of parameters. Whatever parameters you define here in the function definition, that's what you'll need to pass when you call that function. And you can also have nested function, which means you can have another function print, which takes a string, which takes a text, and it just prints the text. So here, instead of returning the sum here, I can call the print text function, where I pass sum to it. So now what will happen is, firstly we are calling the add function here. Inside the add function, it will calculate the sum of a and b, and then it will call the print text function, which will print the sum. So we will do the exact same thing, but we're using a function inside another function. So functions basically help to keep your code organized and clean, and it is advised to divide chunks of your code into functions for better readability, better usability, and also so that you don't have to repeat certain parts of the code again. You can just use functions. You can call that function multiple times to do the same thing instead of writing that piece of code again and again. And this covers our 4 sections of part 1. We first studied about the basics of Python programming language. We started printing output, taking input, what are variables, data types, operators. We used those operators when we were doing if-else statements. We saw how conditional statements are used, how we can check conditions, and through that conditions we can decide where the flow of our code will go. Then we also saw loops, for loop and while loop, which will help us in saving us from writing repeated code, because they execute the same code repeatedly using less number of lines of code. And then we saw data structures. We saw list, tuples, set, dictionaries, and how to use these, access the elements, add and remove elements from these data structures in Python. Last we saw function usage, and all of this that we've learned in this part 1, we'll be using these concepts, these very same concepts, to create projects in part 2 of these series. So make sure to watch that part 2 series and add all of your questions in the comments so we can get to them. Thank you, and see you in part 2.